Some more geometry problems to do. I'll do this one first. I think the instruction says anything that looks like tangent is a tangent if it appears to be, and it says find the value of x. All right, I've got to find the value of x. So these appear to be tangents, so they are tangents. If you have two tangents from the same point, then those segments have the same length. So 4x squared plus 5x equals 6. And I will subtract 6 from both sides. 4x squared plus 5x minus 6 equals 0. Hold on, I want to make sure I'm recording. I am. Now, I take 4 times 6, negative 6, it's negative 24. I want factors of negative 24, and I put that 4 underneath there. Factors of negative 24 that add to 5. So let's see. 3 times 8, how about that? Positive 8, negative 3, plus 8 over 4, minus 3 over 4. 8 over 4 is 2, so this is x plus 2 times x minus 3/4. And I could put that 4 back by the x, but I'm going to solve this for x, so I'm not going to do that. X equals negative 2, and x equals 3/4 or 3/4. So let me see, does negative 2 work? Well, I think either one of them works because negative 2 would be 4 times 4 is 16 minus 10, which would be 6. So that would work. And then the other one works too. It's positive. And 3/4, 4 times 9/16 is 3/4 squared, plus 5 times 3/4. 4 goes into 4 once, 16 4 times. 9/4 plus 15/4 equals 24/4, which equals 6. So either one works. I just want to double check, so neither one made anything negative. All right, there's that one. I'll do this one next. Same principle. If I have one point, and see that those are both tangent to the big circle. So this, 6x plus 5, is the same as this. These two are the same. And on the right-hand circle, I have an external point that is tangent to the circle and 2 points, so both of those segments are the same. So therefore, 6x plus 5 equals 37 minus 2x. I will add 2x to both sides. 8x equals, subtract 5 from both sides, 32. X equals 32 divided by 8 is 4. So I've got that one. All right, I guess I'll do both of these. If this is a radius 6, that's a radius 6. And now I've got a leg that's 6, a leg that's x, and a hypotenuse. I don't think that's a Pythagorean triple. So I've got 12 squared plus x squared equals 25 squared. This is 144 plus x squared, 25 squared. I think it's 625. You can use a calculator. Oh, I'm right, 625 equals 625. So I have x squared equals 625 minus 144, which is 1. 6 is 5 is 12, 8, 481. I don't think that has any perfect square factors, so x equals the square root of 481. I don't think there's perfect square factors in that, so let me go to Desmos and do square root 481, and it comes out to about 21.9. I don't think it can be simplified. 21.9, whatever. What's the units? It doesn't say units. Anyway, that's that one. Okay, here's another one. I have to find x. Well, let me show you this. If that's 5, that's 5, that's 5, and that's 5. So that's a square. So let's see. I know that when I have an external point and I draw 2 lines that are tangent to the circle, those are equal, so that's also x. And then that's 5. That whole thing is 18. Oh, here. So what am I trying to find here? I'm trying to find x. So that's 18, and this is x, so this is going to be 18 minus x. I think that's good. Oh, wait a minute, that whole thing is 18. Wait a minute, wait just a minute. That means this is 13. This part is 13, and so the segments that are tangent to that circle are both 13. Okay, so that makes this whole side 13 plus x. Okay, now I've got it. So this side is 5 plus x, this side is 13 plus x, that's 18. I can use Pythagorean theorem. 5 plus x squared plus 18 squared equals 13 plus x squared. All right, I'm just going to use a calculator this time. 18 squared ends in a 4, I know that. 324. So this is x squared plus 10x, I'm foiling it, plus 25 equals, what's not equals, what's 18 squared again? 324 plus 324 equals, foiling this, it's x, I'm actually foiling x plus 3 times x plus 3. I know I wrote 3 plus x, but you can write it either way. X squared plus 6x plus 9. The x squareds cancel. 10x minus 6x, I'm subtracting 6x from both sides, is 4x. Have I done something wrong here? X squared, is it 13 or, it's 13, not 3. Yes, I have done something wrong. That's 13 plus x squared, so it's x plus 13 times x plus 13, or 13 plus x times 13 plus x. Why don't you correct me on these things? Okay. So I get x squared plus 26x plus 13 squared, which I believe is 169, is plus 169. Okay, so now I'm subtracting 10x from both sides. The x squares cancel. This is 16x. I got 324 plus 25 is 349. Minus, I'm subtracting 169 from both sides. I get 16x equals, there's a 0, 6 and 8, and 180. So then x equals 180 divided by 16, which is 90 over 8, which is 45 over 4. But what is 180 over 16? It's approximately, well, it's exactly 11.25. So x is 11.25. Let me just make sure my 45 over 4. Yeah, same thing. Okay, so there's that one. I'll do either one of 26 or 27. I'm choosing 27. Pulleys. The figure shows a pulley system in which a belt is wrapped around 2 pulleys so that one can drive the other. RS is tangent to circle Q at R. So that means this, if it's tangent, and that's a radius, that's a 90-degree angle. And I'm going to write this in red. So there's a 90-degree angle. And to circle P at S. So this is a 90-degree angle at S. QT is perpendicular to SP, QT to SP. Well, they've already drawn that in, but that means this angle is also a right angle. And LR, oh, man, I can't. Q and P are the centers of the circles. QR is 2, PS is 8. I'll put those in a minute, but first, write a paragraph proof. Well, paragraph proof, I'll just say it, and then you can write it. Since this line, RS is tangent to circle Q at R, that makes RQ perpendicular to RS. Wherever a segment is tangent to a circle, it is then perpendicular to the radius at that tangent point. So that angle R is a right angle. Same thing with angle S. Since RS is tangent to circle P and PS is a radius, then this angle RST, this angle right here, RST, is also a right angle. And then if this angle is a right angle, then the angle next to it on the line is a right angle, 180 minus 90. Now I've got this figure here, and three of the angles inside this four-sided figure are 90. In a four-sided figure, it's n minus 2 times 180. 2 times 180 is 360. 360 minus 270. 3 times 90 is 270 is 90. That means the other angle is a right angle, angle RQT. And since all four angles inside this four-sided figure are right angles, it is a rectangle by definition. That's a paragraph proof. Okay, now let me get rid of all that red. I guess I'll leave the angles in there, and then I'll write these measures for the next parts. So it says QR is 2. Man, I'm going to have to really zoom in. Mr. Camera, zoom. QR is 2. Since this is a rectangle, if QR is 2, ST is also 2. And PS is 8. Well, if PS is 8, that means PT is 6. 6 plus 2 is 8. And what else do I have? And, oh, it gives me one other thing. And, come on, and what? PQ is 12. PQ is 12. All right, so I have a right triangle. 6, 12. Well, this looks like a 30, 60, 90. The side opposite 90 is double the side opposite this angle, so this must be 30. This must be 60. And that must be 90. It's double. And remember, it's x, 2x, and then x square root of 3. 6 square root of 3. So what's it asking? It wants find RS. Well, if that's a rectangle and QT is 6 square root of 3, RS is 6 square root of 3. So RS is 6 square root of 3. And measure of angle P, well, I already did that for the last part. Measure of angle P is 60 degrees. Equals measure of angle P. All right, so I've worked a selection of problems from that worksheet. If you see any of these other problems on there, I'll hold on it for a second, and you need help with it, like number 26 or 21 or 20, just let me know in the comments or send me an email, franktutor@outlook.com, and I will make more videos.